Hi everybody, this is Summer, Mr. Clark, preparing you for the school year. This is some work I did with somebody preparing to take the final today. Whoa. Yeah, all that stuff's gonna be you very soon. But today, we're just doing kind of day, let's call it 1 or 2 for your Precalc course. My job is to run through some of the notes so you don't spend time in class just sitting down and going, why is this so boring? So, we're gonna watch it at home. I'm gonna try to be as entertaining as possible and come in and we can do some practice and talk about it instead of just taking notes. So, what should I already have? Definitely a marker. The goal for today is to talk about domain and range. Most importantly is you should kind of be familiar with these words before. If you need a quick refresher, that is totally fine. Things Summer Marty needs are a clicker for the computer. Or just a faster computer, I guess. I don't know. I'm lucky Michelle took off this out of the YouTube video. Maybe not. Oh, hey, Mr. Mark, what do we got here? Domain. We are talking about all x values or inputs of some function. So, x values, inputs, all things that have to do with the domain. What things can we plug into our function? Range. This is talking about y values. What are the outputs that we can get from our function? Now, that is something you probably have not seen before. In pre-calculus, we're pulling together a lot of strands that you guys saw earlier in your math careers. And we want you to be able to analyze new topics and to think about things not kind of in these isolated chunks. I learned how to do this one way, and then I learned how to do a similar thing another way, but how things are connected. So when you see a challenge, we want you to be able to have an understanding and help yourself out, thinking about it graphically, numerically, algebraically, and also just when there are words, right? When there's not a representation that you are used to. If you're in Ms. Schultz's class, you will see this acronym a lot. But if not, and you're stuck with me, unfortunately, this is what it looks like when you run down the stairs at BCCS. Here it is for everybody in Ms. Schultz's class on a graph, numerically, algebraically, and in words. Understand when things are the same and connected, but in different forms. Back to the video, sprint, 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 sprint. Hi, 10th grade hallway, that used to be you guys. Ooh, if you're in my class, it's often coming to the 3rd floor every day. That is a bummer for you. Okay. Okay, I'm back. Hopefully the video is centered enough. I guess we'll find out if I have to do it again or not. Okay, first things first. On a graph, domain and range. We said domain was all of the x values. So, which axis should we look at? The x-axis. When I look at this graph, which values on the x-axis have a point on this function? Which x values here have a point on this function? And if this goes on forever, everything from negative infinity all the way to positive infinity will have a value on this graph. So the domain is from negative infinity all the way to positive infinity. And I used round brackets here, not square brackets, because I wanted to show that we don't actually ever get to infinity. It goes forever, so I'll never use a square bracket notation when we get to infinity. I could also say all real numbers. And a nice shorthand for that is this symbol you might see Mrs. Schultz or myself use. This kind of fancy R, all real numbers with the double lines. The range. what y values are possible when I look at this function? Well, can I get a y value of 2? Certainly. At this point, I have a y value of 2. Can I get a y value of -8? Absolutely. And if this goes up forever and this extends forever, we can also get every single possible y value. When I look at this graph, there is no y value that we will not reach. That's about as good as it gets when I draw infinities, so you guys should get used to that for the year. Our second graph. When you look at this, what is a key difference between the first and second graph? Here, this arrow, these arrows extend this graph forever. Well, this graph is fixed, it stops. So I think about what x values have a point on this graph. At -3, there is no point on the graph when x is -3. But at -2, we have our first x value. So I can start at -2, and I want to go all the way until at 1, yes. At 0.5, yes. 0.6, yep, there's a value there. All the way until 5. And because I actually do have a value at -2, I want to include it in my domain. That's why I would use a square bracket. Another way of saying this is that I want all of the x values starting at 2 all the way up until 5. For the range, it's a pretty similar process, just with the y values. You can use either notation, whatever is more comfortable to you at this point. But the lowest y value I have on this graph is at 1, and I have every single y value starting with 1 all the way up until 7. So I can say from 1 to 7. I like this notation because it saves me time writing. You truly can pick whatever you prefer. A couple more domain and range questions from looking at graphs. For domain, what x values here have a corresponding point on this graph? These arrows extend forever. I have all real numbers. Now when I look, the question I'm thinking is, what y values are possible or exist on this graph? It is not all of them. What y values am I missing? I'm missing every single thing above the y value of 2. So my range, what y values are possible, are all of the y values that are less than or equal to 2. Another way to write that is by saying I start at a low y value of -infinity, and my highest y value is 2. And again, I never reach infinity, so I have a circular bracket, a regular parentheses there, and a square bracket here, because I actually have a y value of 2 on this graph. The absolute value picture, like the parabola similarly, the domain is everything. Because for any x value I pick, 2.15, there is a point on this graph. If this goes forever, -50 will have a point on this graph. But the range starts at 0, which is part of the range, so I have a square bracket, and goes on forever. Every single y value of 0 will have a point on this graph. So all y values greater than 0 are part of the range. Algebraically, I want to think about what x values could I possibly plug in to, animated slides. Algebraically, to find the domain, what x values can I plug in And so the question is, when would I not be able to plug in an x value? So I like thinking of, are there any problems? If I plug in an x value, could that create a problem for me? So when I think about x squared, and I try to plug things in, could I find f of 0? Sure, I could plug in 0 and I would get 0 squared, no problem there. Could I plug in negatives? Was plugging in negatives somehow an issue or a problem? -2. Yep, I can do negative 2 squared, and that is not a problem. I can figure that out. If I plug in, I don't know, fractions, is that okay? 1/3. Yeah, you might not be happy with me, but yeah, 1/3 squared, I can definitely do that. There are no problems. There is no x value that I cannot plug in here. So, I say, all real numbers is the domain here. For f of x equals 2x plus 4. Same mentality. What x values can I plug in? Are there any problems? Negative numbers I can plug in for x, no problem. 0. Fractions, all those things I can plug in for x and get an output with no problem. Any big positives I can plug in. So once again, our domain is all real numbers. From negative infinity to positive infinity, again, these two things mean exactly the same thing. Now, I have the square root of x plus 4. I can kind of run through a similar thing that we did before. If I plug in 0, do I have a problem? Well, I have the square root of 0 plus 4. Nope, I can do that. 0 plus 4 is 4. Square root of 4 is 2. That's awesome. Now I try negatives. If I plug in negative 10, I get the square root of negative 10 plus 4, which is the square root of negative 6. Now that's a problem. What x values can I actually plug in? And the problem we're running into is I cannot have any negative number inside of a radical. So my thinking here is I cannot have a negative inside that radical or square root. I can't have a negative number inside the square root. But we haven't answered the question, what is the domain? If I can never have a negative inside of here, the smallest number I can have is 0. So what number can I plug in to give me 0? That's kind of this tipping point. If I can make something bigger than 0 in the square root, all set. But negative less than 0, no good. And it turns out that number is negative 4. If x equals negative 4 and I plug it in, I get the square root of 0, which is 0. Now the problem comes from if I plug in negative 5 or 6 or 7, I run into the same thing I did when I plug in negative 10. So I can plug in negative 4 and everything bigger. But anything less than negative 4 is a problem. We cannot plug that in. When I look at the bottom, I could guess a lot of different numbers and plug them in without an issue. Fractions, if I plug them in, no problem. Negatives, if I plug them in, negative 2 plus 1 in the denominator, that's fine. The issue is here that I could run into is I have to be careful that I know I cannot divide by 0. And if I can't divide by 0, that will help me figure out what x values I can plug in. Well, what x value would I plug in to make me divide by 0? I'd have to plug in negative 1. With negative 1 in for x would give me a 0 in the denominator. So if I cannot plug in negative 1, then my domain is every single number except x cannot equal negative 1. So what I'm saying here is every number is good out except for negative 1. Negative 2, fine. Negative 1.1, fine. But x cannot equal negative 1. That is the only problem. The domain is everything except that. So algebraically, sometimes it takes a little bit more time here than when you're on a graph and you have everything already visualized nicely for you, and you can just read the graph. But we have two major problems here. You can't have a negative inside of the square root, and you cannot divide by 0. Those are two kind of recurring things that when I think about, when will my domain not be all real numbers? These are some algebraic situations that create those problems.